Welcome to Reimagined Energy, where we explore the technologies and trailblazers transforming how we power our world. Today, I'm talking to Dennis Korosis of Volta Insights and Insight AI about the future of electrical asset intelligence. These two innovations are redefining how industries monitor, manage, and optimize energy systems in real time. From detecting hidden power anomalies to predicting equipment failures before they even happen. This conversation uncovers how data, AI, and hardware innovation are converging to make electrical systems smarter, safer, and more sustainable. Coming up next. Hi, Dennis. Welcome to the podcast.
Hi, Maria. Good morning to
It's
you.
great to have you here, and you're coming from Toronto, beautiful Toronto. So I was looking through your website, and you're doing a lot of work, on the predictive side and using data, to really give a good reading into the industries. How did the idea for Volta Insights and also your Insight AI, how did that all come about?
Yeah, great question. Thank you. It all started from some consulting and contracting that I was doing in industry.
Mm-hmm.
Effectively, there were a lot of problems with motors and VFDs,
Right.
stuff blowing up, and no one could actually understand why. And so I would have to go show up with oscilloscopes and try to solve these problems. And it was just a really challenging issue. So I thought there must be a better way to do
Right.
this. And that's how it all started.
Interesting. No, what about there must have been a lot of breakthroughs, like on the technological side, that made predictive asset monitoring, viable, like on a large scale. Yeah.
Right. Yes. So there's a couple of things there. One is the cost of microelectronics came down. So you get a lot of processing power at the edge whereby you're able to do some waveform captures and measurements and be able to process that to give you an idea as to what is happening. And then the cloud is also a big help because now you have access to other people who can look at the data, like our engineering support team, to actually analyze and figure things out to help the customers. A lot of customers don't want to look at waveforms and don't necessarily want to try and understand what is happening. So we act as their in-house electrical engineer fundamentally by having these remote units reporting information up into the cloud that we can leverage to solve problems.
Many industries face, unpredictable downtimes, and hidden electrical issues. All of these, cost money. Time is money. When a big
Yeah.
part of machinery goes down, time is ticking. So walk us through a specific case where Volta Insight, where you've identified problems that perhaps others have missed or just didn't, pick up on immediately.
Sure, yeah. So the real secret sauce is the continuous waveform captures that we do and being able to detect anomalies within those waveforms. So I'll go to one very specific example. And within industry, you have a lot of conveyor belts, right? You may have a mixer of chemicals, whatever the process may be. So if you lose one motor,
Mhm.
it's not the cost necessarily of the motor that's really expensive. Maybe it's a $20,000 motor to replace, but it might take 8 hours to actually replace that motor. And that 8 hours may turn into $1 million of downtime. And that's the more critical component that we're trying to address. So, in a specific example, we can see small anomalies that begin early, like a contactor starting to fail. We can see that in the voltage transients that happen. So, contactors will start to bounce effectively. And if you can get them early enough, then you can change a $200 part, which takes 15 minutes, instead of going to failure on your motor, which will take 8 hours and a lot more money,
Right.
right? So that's a very specific example, and there's many other things. We can see electromechanical degradation on a particular system using this electrical signature analysis that we use, but effectively it's catching something early and addressing that in its infancy so that you can continue running your operations. That's the key.
What about this is I'm throwing a different question at you, but it just occurred to me. Do you need to set up special monitors or special probes within, like you mentioned, conveyor belts, like in a huge facility? Do you have little sensors all planted all over the place?
So we have nodes, we have our own sensors. We call them nodes and VI
Oh, okay.
modules. Effectively, they measure voltage and current in high frequency, and you deploy them specifically to a piece of equipment. So we will send you a box with the CTs, the node, it's all calibrated specifically for that piece of equipment. Deployment may take like 15, 20 minutes, for example, and it's purely plug and play. There's no thresholds, there's no calibration. We do that before we send that package to the customer.
Thanks. So with power quality issues, they can be subtle yet destructive as well. So what are the most common dirty power, as they say it? What are these problems that you see across sectors? And how does your system detect those anomalies in real time?
Another great
Yeah.
question. So power quality, there's different definitions of power quality, right? Power quality
Mhm.
can be just a continuous problem that's always pre-existing. So if you have a lot of VFDs within a facility, for example, you're going to have a lot of harmonic distortion, as it's called. Now,
Mhm.
that may or may not be a particular problem for your installation, but it's important to know that it actually exists. The bigger problem on power quality is those intermittent problems that no one can identify. So it happens in either milliseconds or it happens for seconds at a time, and no one knows what has just happened because the equipment is not set up to capture it or understand it. So that's our real claim to fame, is being able to find these intermittent problems, which industry calls ghost electrical problems. Oh, there's nothing we can do. No, that's not true. The reality is you don't have the data to be able to solve this particular problem. This is the true value that we bring to industry, to be able to identify those intermittent issues.
So, well, let me ask a question here of when you for it's a scalability, question. Like when you move from one facility to multiple sites, what challenges could arise deploying these nodes that you have in your hardware, connecting them to different applications? But and like when you scale, you have to consider different climates, the power infrastructure, the regulatory environment. So, how do you oversee these challenges or overcome them?
Thing. I think we have addressed the scalability issue in terms of deployment because we get a list of critical assets from our customers. We build out for those critical assets our solution, and then we send them off and the customer installs. The device itself connects to the Ethernet, cloud based. It's like a home Google camera, so to speak. It's plug and play. And there's not much in terms of having to do a setup for the customer side. So the scalability is there, whether you deploy 4 sensors or 100 sensors within a facility, as long as you have a network or we provide a network for you. We also have LTE hubs in case no network is available. Then it's really plug and play and you can scale. At the utility level, if you want to go point to point across major geographies, for example, we also have a solution including GPS time syncing and so forth, which is very useful for finding transients. So I think we've addressed a lot of the scalability issues. And we're always working to do better. So if there's a corner case where something may not work, we will work with the customer to solve it.
Data is central to what you do. You have mounds of it. Every second you're getting intel. How do you ensure the accuracy, but also the security of it all, and how and the usability of the data you're collecting? The other question is, how do you if you look at historical data, probably you probably would take a year to really get a good sense of the fluctuations, machinery that can be, using it efficiently, shutting it off during downtime. Maybe, I guess, back to my first question is the data. How do you secure it? and use it.
Yeah, so there's a lot of data. On the first question, how do we secure the data? We have SOC 2 compliance that we're going through, so that's one check mark for us in terms of security, and we have a lot of it. So through our cloud, we have done some smart things in terms of, let's call it compression algorithms and picking out what's important and what's not important and being able to really sort of compress effectively all that
Really
data
cut
and
out the
keep the
noise, really,
yeah,
essentially.
cut out the
Yeah.
noise. Yes, absolutely. So, and our data plan, let's call it, is infinite. We have, limited amount of data. It's not 3 months or 4 months. If you've deployed on a particular asset, we keep the data from day one, which might be years. So you can go back and reference. And in terms of learning an asset and understanding how quickly we can baseline on data, we need days and possibly a week or two. And from there, we can do very accurate anomaly detection. So I think we've addressed a lot of the problems that have previously been very front and center with a lot of the metering, electrical metering techniques for us.
What about as more businesses lean into sustainability and energy efficiency? Do you have any examples of how better electrical monitoring when looking at data, like how this all directly leads to greener operations?
Absolutely. So everyone's concerned about carbon footprint. Anytime you have waste, there's carbon footprint associated with it, whether it's equipment failures or even a process failure, right? So you may have a process, chemical process, for example, you have a batch that you're mixing. If that motor goes down, then you may have to get rid of that batch. You may have to empty that batch and it might go to waste. So that might be tens of thousands of dollars of just material that goes bad. So if you're able to prevent failures on a motor or on a contactor, for example, and it's a 15-minute shutdown or a 10-minute adjustment, that you can see in the electrical signature, then you've prevented maybe 30 or $40,000 of material not going to waste, and that's a huge benefit to the carbon footprint.
Looking forward to the next 5 to 10 years, things are moving so quickly, especially on the hardware, the AI side, but also how industries and utilities and regulators, might change in all of this. So where do you see yourself? Where do you see your company in 5 to 10
Yeah,
years?
another amazing question, probably the most amazing question. I think what we've built is a small sort of step, the foundational step of getting all that automated electrical data into one spot and being able to analyze it and understand it. So as we've done that, I see a future where there's a lot less misunderstanding or guessing on the electrical side as to what might be starting to fail. I think in the past a lot of in the automotive industry, right, you go to get your car fixed, something is misbehaving, a lot of mechanics will just throw parts at it until the problem goes away. It's somewhat similar in the electrical industry, but the costs are much more significant. So if you can identify precisely where the failure point is, then you can address it quickly. And I think we've built the foundational model. And I think there's a lot more work to be done, but we're going to get a lot more accurate as to how to address issues and how to create prescriptions automatically so that, a technician on site doesn't really have to think too much or do too much guessing, can just look at the data and say, yeah, it's recommending I go take a look at this. And, we get very accurate in those prescriptions.
Well,
That's the
exactly, because technicians, paying for their time, and what probably before would have taken 2 to 4 hours to diagnose a problem, the problem is already pre-diagnosed for them before they arrive on site, and then they can fix it. So it's a cost savings for a lot of these
absolute.
companies too.
ab-
And of course, knowledge is power. Get it?
Yeah.
So, and very much that. And before I let you go, I'm looking at a stuffed animal, a dog behind you there. So tell me the story about your mascot, I guess.
That's our mascot. We call him Maxwell. We named him after Maxwell's equations because obviously we use a lot of equations to solve problems in the field. So that's our little
Well,
guy.
that's great. Thanks, Dennis, for joining me today. I really appreciate this, and all the work that you're doing. It's just going to continue to grow. And
Thank you, Maria.
thanks a lot.
Thank you for having me on. Appreciate it.
Wasn't that an interesting look into how predictive analytics and AI are reshaping the way we understand energy at its core? A huge thank you to Dennis from Volta Insights and Inside AI for sharing how smarter monitoring leads not to only operational efficiency, but a meaningful step towards sustainability. If you enjoyed this episode, be sure to subscribe and share Reimagined Energy with your network. Until next time, I'm Maria McGowan, inviting you to keep imagining what's possible when we innovate with purpose.